All right, algebra students, today we are going to use the Pythagorean theorem. Our learning target is I can prove or disprove that a triangle is a right triangle using the Pythagorean theorem. So there are multiple uses for the Pythagorean theorem. Just a reminder of what the Pythagorean theorem is. It says in the box, in a right triangle with the legs A and B and hypotenuse C, a squared plus b squared equals c squared. But the cool thing about the Pythagorean theorem is that the converse of that is also true. So if we take the sides of a triangle and we plug them into the formula, a squared plus b squared equals c squared, with c being the longest side, if the numbers that we substitute or plug in for the variables make that equation or that formula equal on both sides of the equal sign, so if a squared plus b squared does in fact equal c squared, then we know that that has to be a right triangle, and that the angle between the two legs has to be a right angle. So we're going to use that little piece of knowledge to determine if triangles are right triangles or if they're not right triangles. So the first one here says, is this a right triangle? Prove or disprove using the Pythagorean theorem. So I'm going to go ahead and start by rewriting the Pythagorean theorem again. We have a squared plus b squared equals c squared. And the first thing we probably should do is identify the sides, so a, b, and c. And a and b are interchangeable. So the one that's really the most difficult for students usually to determine which is which is the hypotenuse. And the hypotenuse has to be the longest side if it's a right triangle. So we're not sure if this is a right triangle yet, but if it is in fact a right triangle, the longest side has to be the hypotenuse, or c. So I'm going to put a little c here by the 9 because that's the largest number. And then the other side, it really doesn't matter. You could switch these. It's not going to matter because we know from the commutative property that a and b in our formula are interchangeable. So I've identified my a, b, and c. And now all I'm going to do is I'm going to take those values and actually plug them in underneath the variable. So I'm going to plug in, the mathematical term we use is substitute, right? So instead of a on this one, I'm going to write 6 squared. So I just took this value and plugged it in or substituted into my formula. And then plus b squared, which is 8. So 8 squared equals c squared, which is 9 squared. So I just took those two and replaced them with each other. Now, if you remember what the exponent represents, it's how many times we're going to multiply the base number by itself. So a lot of students will say, oh, 6 to the power of 2. Well, 6 times 2 is 12. That's not what 6 to the power of 2 means. Remember, 6 to the power of 2 means 6 times 6. And I'm going to show you this on this one, and then the next ones I'm not going to show you or write all this out. So 6 times 6 plus 8 times 8 has to equal 9 times 9 for this to be a right triangle. Now, we know that we need to multiply before we add those together because of the order of operations, which says multiplication comes first. So I have 6 times 6 is 36 plus 8 times 8 is 64 equals 9 times 9. 9 times 9, which is 81. Now I already can tell, like you should already look at this and say, oh, those are not equal. But we're going to go ahead and finish this out. 36 plus 64 is 100. 100 does not equal 81. So I drew the line through it, and then I'm going to write on the bottom, no, this is not a right triangle. Because I just proved it above that the values of the sides, the side lengths, do not work when I substitute them in for into the Pythagorean theorem. If it was a right triangle, the left side of my equation would equal my right side. In this case, it does not. So we're going to do this a few more times. I'm going to go through a little bit quicker since we just did an example. It says, is this a right triangle? Prove or disprove using the Pythagorean theorem. So the same thing. I always like to start by rewriting the Pythagorean theorem. And now I'm going to do the same thing where I'm going to identify the longest side, which is over here, and then the other two, it really does not matter. Okay, so I'm going to rewrite my Pythagorean theorem, but substitute in the values instead of the variables. So a squared, which is 8 squared, plus 15 squared has to equal 17 squared. Now I'm gonna have to get out my calculator because I don't have my perfect squares memorized that high. I know that 8 times 8 is 64. I do know that one. 15 times 15 is 225. Some students like to do this side all the way down first. So 225 plus 64 would be 289. And now we can go ahead and bring the 17 squared down in my calculator. 17 times 17 equals 289. So since those two values equal each other, yes, this is a right triangle. I'm going to go ahead and keep going here. This one says, is the triangle with the side lengths of 5, 8, and 11 a right triangle? Prove or disprove using the Pythagorean theorem. So there's not a picture, but I can still determine which are the legs and which are the hypotenuse because the hypotenuse is always the longest. So I could sketch a triangle, or I'm just going to write the letters above these three values. Now, always start again with writing the Pythagorean theorem because a lot of students, you'll be surprised, they just do A plus B equals C. And they're like, well, 5 plus 8 doesn't equal 11. That's not how this works because we're using multiplication in here. So you have to multiply or do the exponents before you add them together, okay? So we're going to go ahead and plug these in. 5 squared plus 8 squared equals 11 squared. 5 squared is 25 plus 64. If I add those together, would be 89. Uh-oh, I don't think these are going to be equal. And I know that the square, 11 squared, 11 times 11, I do have that one memorized, is 121. So these do not equal each other. So not a right triangle. We're going to do one more like this. So it's another one where they didn't give us a picture, but they said is a triangle with the side lengths of 20, 21, and 29. So I'm going to go ahead, A, B, and C, because the hypotenuse, or C, has to be the longest. A squared plus B squared equals C squared. So I'm going to go ahead and plug these values in. 20 squared plus 21 squared equals 29 squared. 20 times 20 is 400. I do know that one. I don't know 21. Let me see. 21 times 21 equals 441. So this is going to equal 841. Now I'm going to go ahead in my calculator and put 29 times 29. Oh, it's 841. That's exciting. So yes, this is a right triangle. And we just proved it by showing that the A squared plus B squared does in fact equal C squared.